Yep, I just totally looked to make sure we were recording. Chapter 18, Lecture 3. Now I'm on a roll. I'm just going to bang these babies out, right? The endocrine system is pretty cool. And part of what I keep forgetting to talk about is how itchy my nose is. No. Oh, hey, check this out. This is cool, and I saw it the other day. My little Christmas cactus underneath my Dr. Seuss plant. It's totally, oh, you can't see it because my arm's in the way. It's all flowering, so pretty. I saw that and I go, yay. This kooky plant, I mean, you can't even tell. My Dr. Seuss plant just is like a monster on my plant rack. I don't know what I'm going to do with that thing. I've already chopped it up into bits and now it's like, the Greek mythology when you cut off one head and three heads sprout. That's what's happening with that creature. So, we need to talk about when things don't work out that well, as in addition to, when they do. In my last lecture, I talked about growth hormone. I guess it's at the end of the lecture with the disorders, because that's where all my notes are. But you can have pituitary dwarfism if you're not making enough growth hormone. So that's why those annual checks with the kids are so critical, because they can, chart them, and there's artificial growth hormone that they can give kids to hopefully stimulate growth and, address that deficiency. And there's gigantism if you're making too much. This is before puberty. After puberty, if your pituitary gets wonky and you start making too much growth hormones, like your ears get really big. I don't mean to laugh. It's called acromegaly. Hands, feet, cheeks, and jaw just get really enlarged because you're not having the body-wide growth spurt. Those plates have sealed. That's long gone. All right. I'm going to try to remember to talk about disorders with the next one. So, my next gland that we're talking about is the thyroid gland, and it comes with a story. So when I was in high school, in my home ec class, because girls took home ec, there was this funny chick, and her name was Kelly Childs, and she was just freaking hysterical, and I always loved sitting next to her because she was just funny. And I think I laughed just thinking how funny she was. And, she was kind of a larger person. I don't care. She's funny. I loved her to pieces. So, anyway, I was kind of I don't know. I was a geek in high school and I didn't have a lot of friends. I just had my friend Heidi, who we're still friends with. But, anyway, so not a lot of friends, but, talk to everyone, but nobody's really a friend. And just, get through high school like everybody else. So, if you fast forward 5 years after I graduated. I'm dating Roger because I met him right when I graduated college. And he brings me to a picnic that his boss is having. His boss lives on a lake and has a boat and all this stuff. And I'm like the most awkward person you've ever met. And I just go and I pet the dog, right? I'm that person. Where's the dog? Okay, I'm over there by the dog. I don't know how to talk to people. And so, I'm at this party. I'm talking to this one individual that's also kind of an outcast. I don't want to say a freak, but we're all freaks. Well, kind of, uncomfortable in social situations like I am. And then this beautiful person comes up to me, and I'm like, dude, I don't know pretty people. Pretty people don't talk to me. And she's like, hey, Laura. I'm like, hey, hi. Okay. Do I know you? What do you say? So again, even more socially awkward. And her boyfriend's like, oh my God. And she's like, it's me, Kelly. I'm like, Kelly. And she's like, Kelly Childs from high school. I'm like, no way. You look a lot different. And she had a thyroid disorder. She had hypothyroidism. So her thyroid wasn't making enough hormone, which affects the whole body's basal metabolic rate, their BMR. And she got on medication for her sluggish thyroid after high school and dropped all this weight, and instead of having curly, short, blonde hair, it was like long. She looked like a model. I'm like, well, you're pretty gorgeous. So, you know, I'm always kind of hoping maybe I have hypothyroidism and I'll get on medication and it'll help me lose weight and maybe I'll even get pretty. Hasn't happened yet. All right. So we are talking about the thyroid gland. And there's a lot of disorders associated with the thyroid. There's hypothyroidism, hyperthyroidism, goiters, and Graves' disease. Those are all sorts of things associated with a malfunctioning, dysfunctioning, I don't know, thyroid gland. So the thyroid's in the upper neck. Looks like a little butterfly. We're not going to go into the specifics of the hormones and the chemical makeup of them, but the thyroid gland, whoops, let me hold the pen the right way, makes two kind of subunits. So one is called T4 or tetraiodothyronine, and the other is T3, which is triiodothyronine. And together they make the thyroid hormone. Now, the thyroid hormone needs iodine to be made. And the thyroid hormone, is there a thing? Hold on. Holy Moses. Here we go. Well, let's go into this one. I'm going to jump around a little bit. So, why does the thyroid, so here's my thyroid gland down here, okay? This is my thyroid gland. Hunters out there shooting, it's wonderful. Okay, so the thyroid hormone makes the thyroid gland makes thyroid hormone, and high levels of thyroid hormone go back and they talk to the hypothalamus. If I have low levels of thyroid hormone, T3, T4, that will be detected by the hypothalamus and it will make a releasing factor, thyroid releasing hormone, go in that portal system and it will go to the anterior pituitary. The anterior pituitary will release thyroid stimulating hormone, which goes to the thyroid gland and says, hey, make thyroid hormone. Now, let's stay on this for a minute because I said your body, all right, so that's a feedback loop, negative feedback loop. When I have a lot, it's turned off, okay? But let's go back because I said you need iodine. Now, in our developed countries, they put iodine in the salt, right? It's iodized salt so that we get dietary iodine. So, our thyroid hormones can be produced. If you don't have access to iodine, like in third world countries, you're not going to be able to make thyroid hormone. So these low levels are still going to be detected by the hypothalamus and anterior pituitary, and they're still going to be telling the thyroid gland, make thyroid hormone, and it can make its precursors, but it can't make it all, so it keeps making like the parts it can make, and the thyroid gland gets very enlarged and it becomes a goiter. So if you saw that goiter, has to do with a malfunctioning thyroid gland, usually because iodine is not available. All right, well, let's go back here. So we've pretty much talked about it. All right, so the thyroid gland is this little butterfly right below the larynx, across from the trachea in your upper neck area. And this we're not even talking about other than that it's an 8-step process to make the thyroid hormones, and I need iodine. Right? Oxidation of, iodide. Iodide is iodine. Okay, what does the thyroid hormone do? The thyroid hormone increases your basal metabolic rate, helps maintain your normal body temperature, helps you make proteins, increases the use of glucose for ATP, works with human growth hormone to accelerate body growth. So it has to do with growth, it has to do with metabolism, and it even has to do with the heart's response it increases the heart's response to norepinephrine, because it upregulates those receptors, upregulates the beta receptors. Let me get my little cheat sheet here. Page 3. What else do I want to say? Upregulates those, yep, development. And it has to do with development and growth of nervous tissue, nervous system tissue. So if infants have a malfunctioning thyroid gland, there's going to be long-term developmental disabilities. So this is kind of an important one, right? What does the thyroid hormone do? Why is the thyroid hormone released? Because the anterior pituitary told it to be. Why did the anterior pituitary tell it to be? Because the hypothalamus told it to. All of this is because I had low levels of thyroid hormone in the blood. Okay? It's always that same story. The thyroid gland also releases calcitonin, but again, they're not really that sure about what calcitonin does, so it's not totally accurate what they're putting on here. And it's released in response to high levels. So high levels of blood calcium stimulate secretion of calcitonin. Tells the body to store calcium, but not really. All right. What is this? Control secretion is increased by the hypothalamus to the anterior pituitary in response to low levels that we just talked about. Low metabolic rate, cold pregnancy, high altitudes. Okay. Principal actions: increasing metabolic rate, stimulating synthesis of proteins, use of glucose and fatty acids for ATP, increasing the breakdown of fats for ATP synthesis, enhancing cholesterol excretion, accelerating body growth. And this is what I was talking about, contributes to the development of the nervous system. Parathyroid gland. What? Two types of cells. Here we go. This crazy thing. So the parathyroid gland is if you take the thyroid gland, which was we just talked about in your upper neck, and you flip it around, you find these 4 little pockets, these little green spots, and those 4 little green spots are the parathyroid gland. Parathyroid gland is pretty much, look at this. Is this all I have? Oh, I guess it is. All right, well, we're going to keep talking. So the parathyroid gland will detect, it's constantly monitoring blood calcium levels. If I have low levels of calcium in the blood, the parathyroid gland will make parathyroid hormone. Parathyroid hormone will do 3 things. Will, say, osteoclasts, we've talked about this a couple times, break down bone. Oh, of course, it's not going to work. To release calcium into the blood. Parathyroid hormone will say, hey, kidneys, reabsorb, hold on to calcium. Don't let any go in the urine. Not lose to urine. And it actually does a 3rd thing, and it will say, hey, kidneys, make more vitamin D. I'm out of room. Hey, kidneys, make more vitamin D. Vitamin D allows calcium to be absorbed across the digestive tract. So it's 3-prong response that parathyroid does. So it says, promotes release of calcium from bone matrix into the blood. That's activating the osteoclast. Slows loss of calcium in the urine. Hey, kidneys, reabsorb it. and increases blood calcium levels by saying, hey, kidneys make vitamin D so that it can go to the small intestine, it can grab onto the calcium and absorb it across the intestinal lining. I don't want to talk about the other half of this. We're just talking about low levels of blood calcium and the parathyroid portion of it. Okay. Yeah, it's only 15 minutes. So our next gland to talk about are the adrenal glands. Adrenal glands sit on top of the kidney. So this big crazy thing here is a kidney, and sitting on top of it are my adrenal glands. And the adrenal glands, like I said, has two different regions. It has an outer adrenal cortex and the inner adrenal medulla. Now, the inner adrenal medulla, we already talked about. That is what releases norepinephrine. I know I call it epinephrine. I told you I'd use them interchangeably into the blood. Okay, being activated by the sympathetic nervous system. Activated by. Okay. The outer cortex actually has 3 regions to it. And each region makes its own thing. Okay. One region makes mineralocorticoids. I want you to know it makes aldosterone. The middle region makes glucocorticoids. I want you to know that it makes cortisol. My heat just clicked on. The innermost region makes androgens. Androgens, this is pre-puberty and postmenopausal. It's knocking on my door. This is our source of like testosterone and estrogen. Because testes aren't working yet as pre-puberty, and my ovaries are either not working yet or they're shriveled up. So that's what I can count on for the other hormone for sex drive and everything coming off of my adrenal cortex. It's that DHEA hormone I was talking about. I never talked about I don't remember what it stands for. Something big and long. Okay, so let's look at aldosterone. All right, I guess we'll just kind of talk about this. So aldosterone is tied into another hormone. Aldosterone is coming off of the adrenal cortex. And it's tied into another one, and this is the renin-angiotensin, and these are hormones made by the liver and the kidneys. Uh-oh, I think I got them backwards. But here's what I want you to know. Here we go. Here's my adrenal cortex. I'm right here at number 10, guys. Adrenal cortex will release aldosterone. We'll talk about why in a minute. And that goes to the kidneys and says, hey, kidneys, increase sodium and water reabsorption. So I hold on to salt. Sodium. Oops, not 2 pluses. And water. That will increase blood volume, which will help my blood pressure. So, if I have low sodium levels, if I have low blood pressure, I have a decrease in blood volume, decrease in blood pressure, that is causing all this other mechanism that we're not talking about right now, but ultimately leading to the adrenal cortex to release aldosterone. Talks to the kidneys, says, hey, kidneys, hold on to salt, hold on to water, increase blood volume, and therefore increase blood pressure. So, of course, it's a negative feedback system. So you want to know what's the stimulus? Low blood pressure, low blood volume, ultimately, right? That's the stimulus for release. I know there's a middleman. We're skipping over the middleman, And we're going right to then the adrenal cortex, what it releases, okay? That's the one hormone from the adrenal cortex. Another hormone from the adrenal cortex is cortisol. I mean, there's cortisol, hydrocortisone, and corticosteroid, but we'll just stick and call it all cortisol. Cortisol has to do with breaking down proteins, getting glucose available. It has impact in like a stress-resistant hormone. It reduces inflammation and it suppresses your immune system. Yeah, I mean, it's known as a stress hormone. So that's what it does. Hold on. I'm sure, is there more? Yep. Increases, they help control. It increases the rate of protein synthesis, breakdown, increased rate of protein breakdown. So it's breaking down proteins. It's not always a good thing. It's increasing the rate of glucose formation, getting glucose in the blood. It's increasing fat breakdown. It's providing resistance to stress, right? It's increasing resistance to stress by decreasing inflammation, by decreasing, that will also decrease tissue repair, tissue repair recovery. So you're going to heal slower when this guy is there, right? But what do you do when you have something going on in your skin? You put on a cortisone cream, anti-inflammatory. It decreases your immune response. Oh, well, we've already talked about this like 3 times in response to this is cortisol. I'm not talking about it again. The third region makes that androgen, right? That's like a sex hormone. And I said, oh, it's DHEA. So DHEA stands for dehydroepiandrosterone. And males after puberty, testosterone takes over. But in females, DHEA is converted to estrogens, and it's all I got. Once I'm menopausal, all estrogens come from the adrenal cortex. So hopefully my adrenal cortex is nice and healthy because I don't want to mess with that part of my body. And we talked about the adrenal medulla with the sympathetic nervous system. What do I have left here? I got the pancreas to talk about still, and I have the stress response. Oh, crap. I forgot. Oh, let's go back because I have, so when we're talking about cortisol, no, not when you're talking about, oh, I guess Cushing's disease, Cushing's syndrome is when you make too much cortisol. What does that mean for the body though? I don't have that in my notes. Addison's disease is when you make too little aldosterone and cortisol. Got to be careful with that one because if you're not making enough aldosterone, it could really mess with your sodium levels in your blood, which is a big deal. All right, well, we'll save some more of that for later. So I have the pancreas and I have the stress response is all I'm going to talk about next. Let's just do it, right? Or should I? Let me see how many slides do we have. I don't know. Okay, that's not too many. Sorry, guys. I'm like, let's just do it. Okay, so the pancreas, remember I said the pancreas was kind of a scary organ because it's both an endocrine and an exocrine. So the pancreas is retroperitoneal. It's behind the stomach, so it's along your back, kind of in the same zone as your kidneys. And it's this, makes all digestive enzymes in one part that go into the first part of the small intestine called the duodenum. Super important for digestion of all food types. And so then I also have 4 different types of hormones being made in the pancreas and the pancreatic islets. But we're just going to talk about glucagon and insulin. They're antagonistic. They're opposites. Insulin tells your body to take glucose out of the blood. Glucagon tells your body to dump glucose into the blood. Let's see. So here's glucagon from the alpha cells. I'll never remember that it's alpha cells, I'll be honest. I get the alpha and the beta all mixed up. So first, let's go with principal actions. Raises blood glucose levels by accelerating breakdown of glycogen. So I have glucagon, the name of the hormone. Glycogen is a long-term storage form of glucose. So it says, hey, liver, dump glucose into the blood. That sort of thing. So it's stimulated by low blood glucose levels. Okay? Stimulate secretion. Exercise and protein meals stimulate secretion. Okay, so let's go to insulin. Insulin is from the beta cells. And insulin is when you have high blood glucose. It will lower blood glucose by telling all the cells, hey, get the glucose, store glucose. It will say, hey, liver, convert glucose to glycogen. And let's just stop making more glucose. So if I have increased blood levels of glucose, that will stimulate these guys to release insulin. Acetylcholine also stimulates insulin because acetylcholine by the parasympathetic vagus nerve has to do with digestion, right? So it's like, well, they must be digesting. And telling the cells to store glucose into cells. This guy saying, hey, dump glucose into blood. All right, so they're antagonistic. They do opposite things. And then I'm not going to worry about somatostatin or the other one. Oh, look at this. I have low blood sugar stimulating glucagon. Glucagon will tell the liver cells dump glucose into the blood, make glucose from other things, raises glucose levels to blood to normal, and then it would be shut off. If I have high blood glucose, that will talk to the beta cells saying, hey, make insulin. Insulin goes and tells the body cells, hey, get glucose into the cells out of the blood. Hey, turn glucose into a long-term storage form of glycogen and start using other things. It will cause blood glucose levels to lower, and when they're in normal range, it will get shut off. Negative feedback. They do opposite things. So if you have type 1 diabetes, maybe you got it as a kid, maybe you got it as an adult. Something happened and attacked your beta cells in your pancreas. They no longer work. Usually it's an autoimmune disorder. So that means that you no longer make insulin. You're not making the message. Okay? No message made. You will be on insulin your whole life. Remember, we talked a little bit about type 2 diabetes. If you have type 2 diabetes, your pancreas is just fine. Beta cell is fine in pancreas. Oh, I forgot to say no longer work. Beta cell is fine in pancreas. You make insulin, the message is made, but it's being ignored by the body cells. Because they've been downregulated by the fat. Make message insulin. So the message is there, but it's being ignored. It's like leaving the mail in the mailbox. And remember, that's because the leptin in adipose tissue downregulated. I'm out of room. I'm not going to be able to say downregulated receptors on the body cells. So they ignore the insulin message, being ignored by body cells. Lose the fat, lose the leptin, lose the downregulation, things go back to normal. Okay. So we have a few miscellaneous things to talk about. I probably have another 5 or 10 minutes to talk, and that will be this chapter. So we're going to bang it out. You have the testes. They make testosterone. We're going to talk about that next semester. Testosterone promotes sperm production and maturation of all the well, it's probably all right here. The male reproductive tract. So here's where I was talking about testosterone. Promotes development and maintenance of male secondary sex characteristics, and also sperm production. In females, we make estrogen and progesterone at the ovaries, which promotes production and release of the eggs and all of our female secondary sex characteristics. Of course, these hormones are just not willy-nilly doing their own thing. They're controlled by the anterior pituitary, which is controlled by the hypothalamus. So, there are other, remember there was anterior pituitary, had hormones of luteinizing hormone and FSH that had input into ovaries and into testes. Okay, pineal gland we talked about, makes melatonin for the body's circadian rhythm. Thymus we did not talk about, has to do with maturing T cells. I'll never ask you about them, I'll never ask you about them, I'll never ask you about all these other ones. I'll never ask you about icosanoids, but I want to get to this stress response. That's why I'm kind of racing through some of this. Okay. So, the stress response. And this is, I like talking about this because it's like, oh, yeah. So, everyone's got stress in their lives, and a little stress is good. That's eustress. That's healthy stress. If it's not good, if it's too much, it's distress. And if you're in distress, you have a couple different levels of response. You have the first stage, which is activating the sympathetic nervous system. And that's all nervous system response, so it's fast, right? But you also have a hormonal response, which is the second stage, and that's the resistance reaction. And it's like part 2, it lasts longer. And if it lasts too long, it will lead to exhaustion. So let's look at this, because you know me. Let me just want to see something. Oh, this is all I have on this? Okay. Got to get to the right part of my glasses, because there's a lot of tiny writing. Okay, so green is the first responders, the first stage. Okay, oops. Green. I see there's no key. Oh yeah, it's right here. Fight or flight reaction. Fight or flight responses. So when you are in stress, your stressors are stimulating, first, they're stimulating the sympathetic nervous system to talk to the adrenal medulla and body, release epinephrine, norepinephrine body-wide, increasing the heart rate, increasing the force of the heart, increasing blood vessel constriction, so making you cold, clammy, and have high blood pressure. Okay, increasing your respiratory rate, getting a lot of glucose into the blood. Now this glucose is going into the blood, but cells are being told not to use it. It's for brain and muscle only. And so your cells are starving. And they start breaking down other things, fats, proteins, because it's for brain and muscle cells only. Other cells, not allowed to touch. It's off limits. which is crazy. So you have elevated glucose in your bloodstream when you're stressed, but you're in sympathetic nervous system mode, and that's just for the brain. That's just for skeletal muscle. You're going to be sweaty. You're going to, shut down your digestive system. You're not hungry, not feeling that well. You're going to retain fluids to increase the blood pressure, have your elevated blood pressure. That's all the first stage. In addition to that, all of these hormones are going to be released. You're going to release, the hypothalamus is going to talk to the pituitary to say, hey, release thyroid stimulating hormone, growth hormone, and adrenocorticotropic hormone. I'm going to go to the adrenal cortex. I'm going to go to the liver. I'm going to go to the thyroid gland. I'm going to increase ATP production. I'm going to increase breakdown of other things to dump more glucose into the blood, even though my normal body cells can't use it. And cortisol, oh, here they are right here, is going to reduce inflammation and suppress your immune system. What does that mean when you guys are under stress? You get sick. Your immune system is being suppressed because of the cortisol. Oh, how crazy is that? I thought I had more written on that in this slide, so give me a second. Let me get to my notes. Ultimately, you're going to deplete your resources, which is going to lead to exhaustion. And I think we're all there right now. And I got to manage this, you guys. Wasting of muscles because of broken down protein. I thought I had this on a slide. Ulcers in the GI tract. Wonderful, right? Exhaustion leads to all of this. You suppress your immune system. You've depleted all of your resources. That makes me sad. I don't want to see that for you guys. So manage your stress. Come up with the strategies. Give yourself a break. You got to save your body because your body's all you got. So there's two separate stages to manage, the short term and the long term. Now, I thought, wow, I don't have anything on the disorders or biofeedback. I thought I had more on biofeedback than I do. Okay. Some of these have to do with, this is increased levels of growth hormone for this guy. This is increased levels of growth hormone, but after puberty. So his jaw, facial features, his cheeks, his ears are a little bit larger. Here's the goiter I was talking about, probably because no access to iodine. Cushing syndrome, so adrenal cortex disorder. This has to do with part of Graves' disease, where their eyes are kind of, exophthalmos, kind of like popping out a little bit, but that has to do with the thyroid, so hyperthyroidism. There's other stuff with Cushing syndrome. It's like this buffalo hump in the back, but I see I don't have any of that either, which makes me think I better change some of the test questions. So I will. All right, my friends, I think this is it. I'm hitting the 40-minute mark. That's a massive file to upload, but it's the last one. So we did it. We're tired. I'm sorry. Hang in there. I'm thinking about you guys. All right, take care, be well, and manage your stress. Take care.